Hi everyone, my name is Abigail. I'm an undergraduate researcher in Amelia Martin's lab. Today, we are going to learn how lizards can communicate and recognize each other, and we're going to challenge you to identify some of them. Animal behavior and communication is one of the main areas of research here at the Martin's lab, where we study this topic using spiny lizards as a model system. Spiny lizards belong to a genus called Sceloporus, which is a very large group of lizards, with more than 90 species that are found across Central and North America. You may have seen them in your own backyard, or even during a hike. They like to rest on the top of fences, large rocks, or tree trunks. You can recognize them by their two most notable features. First, all spiny lizards have these needle pointed scales, which is why they receive their common name, spiny lizards. Second, the word Sceloporus comes from Greek and literally means pores and legs. It refers to these rows of femoral pores that can be found in the inner side of each of their hind legs. In addition, many species have patches of color on the sides of their belly and throat, like this, that can be quite conspicuous. Here in Arizona, we have 7 species of Sceloporus, each with its own distribution. Sceloporus clarkii, Sceloporus graciosus, Sceloporus jarobi, Sceloporus magister, Sceloporus slavini, Sceloporus undulatus species complex, and Sceloporus vigardus. As you can see, many of these lizards occupy the same geographic areas, so they're encountering not only lizards of their own species, but also other species. And different species can look really similar to one another. This raises the question, how do spiny lizards recognize their own species and not confuse them with other species? This may sound like a trivial question, but it's actually very important in the process of formation of a new species. You see, sometimes recognizing each other is not as easy as it may seem. Take these 2 pictures, for example. Save for some cosmetic differences, these 2 individuals resemble each other. Would you be surprised if I told you that one of them is a modern human, just like you and me, but the other is a reconstruction of an Athenderol, humans' most recent relative and a totally different species from which we separated from at least 500,000 years ago? No? Well, how about this? Cuckoo birds lay their own eggs in the nests of other bird species. This is considered a form of parasitism. Here, 4 different nests of Eurasian reed warblers have an extra egg, a little bit larger than the rest, that belongs to a cuckoo bird. When reed warblers fail to recognize the cuckoo's egg as a different species, a cuckoo chick hatches and monopolizes the parenting efforts of the reed warbler. And despite the striking physical differences between the warbler and the cuckoo in size, color, and everything, adult warblers seem incapable of recognizing the chick as a different species. So, how do spiny lizards recognize one another? Well, how would you recognize someone else? Perhaps you could look at their overall physical features, such as body size or body shape. But these things may change over time, and are not always that different. Or you could have specific signals used for recognition, and this is exactly what spiny lizards do. They have at least 2 of such signals. First, head bob and push-up displays. These can be translated into display action patterns, such as these, where the up and down motions of the head are graphically represented over time. And second, they can use the coloration of different body patches to recognize each other. Here is an example of how lizards use their signals to broadcast information about their identity to any potential observers. Head bob and push-up displays are also used during close-range interactions, like these 2 territorial desert spiny lizards engaged in a fighting contest. To study lizard communication, we use robots that we craft from 3D printed models obtained from photographs of real lizards. Using these robotic models, we can replicate the exact motions and color patterns of different lizard species. Isn't that cool? In the next 2 slides, you're going to see 2 of our robotic lizard models performing the species-typical display of an unknown Sceloporus lizard. We challenge you to figure out which species the model is supposed to be. We provide 3 alternate answers with only 1 correct option, and your job is to match the robot's display to one of those possible options. We will replay the robot's display 2 times before providing the correct answer. And you're welcome to pause and go back in the video if you need additional replays. Are you ready? This is our first robot, and the display action patterns of 3 possible species are shown below, with only one correct answer. Remember, the solid line in the figures represent the position of the head or upper body of the lizard over time. As a tip, counting the number of peaks makes it easier to identify the pattern. Are you ready? All right, here we go. Did you get that? Let's play it one more time for the second and last time. All right, the correct answer is Scoloporus graciosus. Let's try a different species now. Are you ready? Here we go. All right, one more time. And the answer for this one is Scoloporus tristichus. Did you find that difficult? Now you might be thinking, these robots don't look a lot like real lizards to me. But the robots don't have to fool us, they just have to fool the lizards. So let's see what the lizards think, shall we? These are images that we've recorded in the field while using our robots to study lizard behavior. You can see how the robot is displaying here, and the lizard is responding to it by displaying back. Here's a close-up of another lizard to which we presented the robot. You can hear the robot on the foreground moving and how the lizard reacts to it. Not too bad, huh? Using robotic lizard models, we can study details about spiny lizards' communication system. For example, modifying the robot push-up and head bob display, or its physical appearance like size or color. We can determine exactly which part of the display is used to recognize and communicate with each other. So, how about you? Have you seen any lizards near you? Now that you know what spiny lizards look like and how they behave, can you tell whether there are spiny lizards in your area? Go and find out. Thank you so much for watching, and everybody stay healthy and safe.